Hello and welcome back to another IB Math Speedrun with me, Vince. So in this one, we're going to be going through some of the trigonometric identities. So let's jump right in. So there are some very important identities you need to know. The first one we've already met, and it's the fact that the tangent of theta is equal to sine theta over cosine theta. This is very important. And actually, because it's identity, we use the third line, so it's actually 3 lines. And we use this symbol to show the relationship is an equivalent and it's true for all values of theta, no matter what. That's why it's an identity. Now the second one we need to know about is equal to sine squared theta plus cosine squared theta is always equal to 1. And we can prove that by looking back at the unit circle. We know that sine theta is equal to y, cosine theta is equal to x, and the radius of the circle is 1, and this is a right-angled triangle. So if we have x squared plus y squared, in this case sine squared plus cosine squared, this should always be equal to 1 no matter where this point is on the circle. It could be there, but it should always be the same. This is called the Pythagorean identity, and it's an important identity, and we can derive a few other things from it. So from this, if you divide everything by cosine squared theta, you get 1 over, if you divide everything by cosine squared theta, you get tan squared theta plus 1 is always equal to 1 over cosine theta squared theta, which is, we can write as secant squared theta. And similarly, if we divide everything by sine squared theta instead, then we get 1 plus cosine over sine, which is cotangent squared theta, is equal to 1 over sine squared theta, which is cosecant squared theta. So these are 4 very important identities that you need to know, and they can be used to solve a lot of problems. They're not all the identities yet, but they are some of the most important ones. With that being said, let us jump into some problems regarding angles. So, the first question, I guess I'll do every other one starting from the second one. I don't know, I'm feeling harder questions today. Anyways, so we have given S is equal to sine theta, C is equal to cosine theta, and T is equal to tangent theta. Simplify. And then we're doing even one. We're alternating starting from the second one. So we have S over square root 1 minus S squared. D is equal to cosine divided by 1 minus cosine squared. And finally, F is equal to tangent over square root of 1 plus tangent squared. So let's start off with the sine over square root 1 minus sine squared. Immediately you should recognize 1 minus sine squared is equal to cosine squared. And if we square root this is sine over cosine, which is simply equal to tangent. So this is equal to tangent theta. Next, we have cosine over 1 minus cosine squared. Well, you should notice this is actually equal to sine squared. So we have cosine over sine squared, which is equivalent to secant times cotangent. So we can label this as, 1 over sine squared is cosecant times tangent. And finally, tangent over square root 1 plus tangent squared. Well, we know 1 plus tangent squared is actually equal to the secant squared. So this is simply tangent over secant squared. So if we but square root, so we have tangent over secant. So from this, we get that this is simply sine over cosine squared. Tangent over secant is equivalent to tangent times cosine, which is simply equal to sine. So this is equal to sine theta. So those are those three out of the way. Next, we're given that x is equal to a sine theta, y is equal to b cotangent theta, and z is equal to a secant theta. We need to simplify. First, we need to, what do we need to simplify? First, we need to simplify y times the square root of b squared plus y squared. So this is equal to b cotangent theta, so b cotangent theta times the square root of b squared plus b cotangent theta squared. And if you look inside this brackets, this is actually equivalent to b squared times 1 plus cotangent theta squared, which you should recognize is equal to cosecant squared. So this is actually equal to b cotangent theta times b times cosecant theta, not squared theta. So this is equivalent to, well, 1 over tangent times 1 over sine is equal, well, I mean, I guess we can't really simplify that one. So this is b squared times cotangent theta times secant theta. So yeah, I don't think we can simplify that more. So it's just b squared cotangent theta cosec theta, not squared, just that. Next, we have, to raise this, the next formula we need to simplify is this one. So we need to simplify the square root of z squared plus a squared over z. So we know this is the square root of a secant cosine, so square root of a squared secant squared theta plus a squared all over a secant theta. And so this top part, well, we can see this is equivalent to 1 plus secant squared, which is equal to tangent squared. So that's equal, 1 plus secant squared, this is z squared plus a squared. Yeah. And that is equal to a squared secant theta is equal to the square root of a squared. Yeah, no, there is an error. They mean to say a squared secant theta minus a squared. So let's just change that. So this is a squared secant squared, tangent squared theta all over a times secant theta. So this is equal to a tan theta over a secant theta. So this is equal to cross those out, and then this is actually equal to just simply sine theta. So that is the answer for this one. Next, we need to solve the following equation. For all values of theta between 0 and 2 pi. So the first one is secant theta is equal to 2. The second one is secant squared theta is equal to 1 plus tan theta. And the final one is 2 cotangent theta, cosine theta, plus 8 is equal to 7 cosecant theta. So let's start with the first one. Secant theta is equal to 2. That's pretty easy. So secant theta is equal to 2. So this means that cosine theta is equal to 1/2. So theta can be, well, 1/2 would be 0 and 2 pi. So this would be 1/3 pi. And also the one on the opposite side. So this would be 2 pi minus 1/3 pi is 5/3 pi. So those are the two values we should obtain. Next, for secant squared theta is equal to 1 plus tangent theta. This is equal to sec squared theta. And we know secant squared theta is actually equal to 1 plus tangent squared theta. Is equal to, and so this is equal to 1 plus tan theta. So cancel that out. Yep. So then we get that tangent squared theta is equal to tan theta. And so therefore tangent theta must be equal to 1. And so the values for this are, of course, pi over 4 and 3 pi over 4. Oh, sorry, 5 pi over 4. So we have 1/4 pi and 5/4 pi. And finally, we have 2 cotangent theta cosine theta plus 8 is equal to 7 cosecant theta. What would be the simplest way to expand this? What I would do actually is if we multiply everything by first sine, cosine, and tangent, then we get 2 times sine theta plus 8 times sine theta, cosine theta, tangent theta is equal to 7 cosine theta, tangent theta. And we know that cosine theta, tangent theta simplifies into sine theta. So we have 2 plus 8, and then this would be sine theta squared is equal to 7 sine theta. Oh, so sorry, 2 sine theta plus 8 is sine theta is equal to 7 sine theta. So we have 8 sine theta squared theta is equal to 7 minus 2 is 5 sine theta. So we have, if we divide both sides by sine theta, we have sine theta is equal to 5 over 8. What values are there for this? I'm actually not too sure, so I'm going to go hit it. Sine minus 1 times 5 over 8, and I get 0.675. And conversely, pi minus this should also be, pi minus 0.675 should also be an answer, so 2.46. Yeah, I don't see why I'm wrong. So that's a bit weird, because actually we can convert this into 2 cosine theta, 2 cosecant theta effectively. So this is 2 cosecant theta plus 8 is 7 cosecant theta. So we have 8 over 5 is equal to cosecant theta. Sine theta is 5 over 8. So we should get these two values. I'm not sure what happened. Anyways, on to the final one. And the final one is to simplify 1 plus 2 sine theta cosine theta all over sine theta plus cosine theta. Okay. Where would we start here? Oh, no, I understand now. So the top part, well, we can say 1 is equal to sine squared theta plus 2 sine squared theta cosine squared theta plus cosine squared theta all over sine squared plus theta plus cosine squared theta. But we know this top actually factors out into sine theta plus cosine theta squared. And so since this is over the exact same thing, this is simply equal to sine theta plus cosine theta. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one.